Hello, Mrs. Wagner here. We're going to talk about mixtures and pure substances. So I'm going to guide you through this slideshow, and then there is a Google assignment at the end. All right, let's first talk about mixtures. A mixture results when two substances are physically combined but don't chemically react. A mixture is a collection of different materials. Take more than one thing, combine them, and you have a mixture. Salt plus pepper equals mixture. Mixtures can be any combination of solids, liquids, and gases. Common mixtures include any baked goods, drink mixes, the air around us, most foods and candy, vinegar, anything mixed with water, blood, brass, and steel, which are combinations of different kinds of metals. There are two types of mixtures, homogeneous and heterogeneous. Homogeneous mixtures is a mixture where the combined parts are uniformly distributed throughout the mixture. You cannot distinguish the different substances of the mixture. Heterogeneous mixtures are when the combined parts are not uniformly distributed and you can identify the substances in the mixture. Here are some examples of homogeneous mixtures. This could be a solid, this could be liquids or gaseous mixture, and it has a uniform composition. No matter where you sample the mixture, the amount and type of components is the same. Coffee, air, natural gas, blood, vinegar, steel, and brass. These are heterogeneous mixtures. These are mixtures that have a non-uniform composition. In other words, its composition varies from one location to another. You can distinguish the different parts of this mixture. This would be soda with ice, milk and cereal, assorted candies, sandwich, pizza, chocolate chips, and soil. So if we were to look at each type of mixture under a very high-powered microscope and take a look at their particles, this might be what a homogeneous mixture would look like, where you have all of the different parts evenly distributed. You don't have red all clumped up together or the green all clumped up together. They're more evenly distributed. An example would be air or steel. Heterogeneous mixtures, you might have one kind of particle all together, so far away you could distinguish that specific substance. Soil and oil and vinegar are two different kinds of heterogeneous mixtures. All right, so how are mixtures different from pure substances? Pure substances, it exhibits the following properties. A pure substance has a fixed melting and boiling point. It has a characteristic taste, color, and odor. It is always homogeneous, always uniform throughout. You never see little pieces or bits different from the actual mixture or the actual substance. We cannot break a pure substance into simpler substances by any physical means. In other words, there's no way to break apart the molecules or the elements of a pure substance. Some examples of pure substances are gold, silver, copper, iron. These are all elements with the same kind of atoms. And these are all elements you would find on the periodic table of elements. Some other examples of pure substances might be molecules, things that are made up of one type of molecule. Sugar, water, salt is another one, baking powder. These have all the same kinds of molecules. All right, so which particle diagram represents just one pure substance? Letter A, letter B, letter C, or letter D? The answer is letter A, and here's why. You have one molecule represented in the picture. You have four of the same kind of molecule, whereas letters B, C, and D, you have two different kinds of particles, not chemically combined. Here's one, here's another type of element, and they are not chemically combined, so they make up a mixture. Letter C is also a mixture. because you have, again, two different kinds of substances. And letter D is a mixture. There's one kind of substance, here's another kind of substance. These two different kinds of substances are not chemically combined. They're not attached to each other. This one is not attached to this one. So that makes it a mixture. Some examples of pure substances: gold metal, copper wire, sugar, salt, hydrogen gas, or a diamond. Here are some other examples of pure substances. Water would be considered a pure substance, and this would be pure water, like distilled water. So there's no impurities mixed in with the water. Oxygen, so that would be a substance that we breathe in. Carbon dioxide, a substance that we breathe out. Gold, iron, baking soda, and tin, and sulfur are all examples of pure substances. The only way to know for certain if a sample is a pure substance is to perform a chemical analysis. However, there are some clues that can help you make a determination. Is it crystalline? Crystals are typically relatively pure compounds, like sugar or salt. A pure substance is usually all one color. The exception is if the matter has unusual optical properties, like it reflects or refracts light. A pure substance has the same appearance and properties no matter where you sample it. If you magnify the matter, it should appear the same everywhere in its composition. The exception is when matter might exist in multiple phases, where water might be freezing or melting ice. If you can write the element symbol or chemical formula for a sample of a pure substance, such as sugar, water, and baking soda, that means it is a pure substance. So sugar is C6H12O6. Salt is a combination of sodium chloride, so that'd be NaCl, and baking soda is sodium bicarbonate. So that's another molecule. Okay, so this is your Google assignment. You're going to get a list of products and material, and you're going to have to identify first, is it a mixture or a substance? Once you've identified it as a substance or a mixture, then decide if it's a mixture, is it a homogeneous mixture or is it a heterogeneous mixture? If it's a pure substance, is it an element, which would be just one kind of atom, or is it a compound, which would be two kinds of atoms that are chemically combined, like water, H2O, or salt, sodium chloride? That would be a compound. Okay, so here's a couple of examples. The first two: aluminum foil is a pure substance. Aluminum is on the periodic table. So aluminum foil is made up of just one thing, aluminum. That is an element. Air is a mixture of different kinds of gases, like oxygen and nitrogen and carbon dioxide and water vapor and argon and all other kinds of different gases. So that makes it a mixture. And it's uniform throughout. The air, you can't see different pieces of the air or parts of the air, so that makes it homogeneous. All right, so go ahead and go into Google Classroom, pull up the assignment, and we'll get started on that.